Dryad's system for early detection of wildfires is called Silvanet Suite. It consists of 4 components: the wildfire sensors, the mesh gateways, the border gateway, and the cloud platform. Silvanet provides a large-scale sensor network that detects a wildfire in minutes and sends the alarm to your cell phone or other devices. Watch this video to learn how to install Dryad's Silvanet. For detailed installation support, please refer to the user manual or contact us. Dryad's Silvanet Suite. The devices.
Hi, I'm Eric from Dryad. In the following, I will give you a brief overview of the use and functionality of each device. The sensor's primary function is to analyze the gas composition of the air. If the gas composition of the air changes due to the forest fire, the sensor will detect this within minutes and send an alarm using the mesh network.
The AI-based sensor is like a digital nose. It can reliably differentiate between natural smells and a forest fire. The sensor also monitors the microclimate of the forest by measuring temperature, humidity, air pressure, and air quality. The gas sensor is located behind a membrane, protecting it from water and dust. The tree nails are made of oak. They do not harm the tree. Instead, they grow with the trunk over time. And these are the spacers. The spacer allows the sensor to hang vertically so that resin and sap are kept away from the gas sensor and the solar cell.
The tree nails are meant for permanent installation, while the crop wire is suitable for temporary installations. Later, when setting up the network in the forest, I'll show you how to use the spacers together with the nails.
The sensor uses LoRa to connect to the internet via the mesh gateways and the border gateway. The gas measurement as well as the sending of the data via LoRa is very energy efficient and can be operated completely on solar power. For 24-hour operation, the sensor incorporates supercapacitors, which power the sensor at night time. Note that neither the sensors nor the gateways contain any lithium-ion batteries. The border gateway connects the mesh network and sensors to the cloud platform using 4G, LTE-M or NB-IoT, or using a wired Ethernet connection. It communicates with the Silvanet cloud in both directions, receiving data from the sensors and sending updates to all devices in the forest.
This is the border gateway. It is supplied with 2 solar panels and all the accessories needed to install it. The border gateway is a compact design. All the antennas and wireless interfaces are integrated into the border gateway itself to protect it against external influences. The NFC tag allows you contactless communication between the gateway and your smartphone.
After installing the border gateway in the forest, use the Silvanet deployment app on your mobile phone to register the device in the Silvanet system and run a connectivity test. The test ensures that the border gateway has a stable connection to the internet.
Later, when we install the device in the forest, I will show you how easy it is to run the test. The plugins for the PoE and the connection cables to the solar panels are located at the back of the device.
There are connectors for 2 solar panels, PoE, and a SIM card.
The sockets are protected with watertight caps. To connect the solar panels and the PoE, unscrew the caps, insert the cable plugs, and tighten the connection.
You can power the gateway using PoE or just using the solar panels. We recommend operating the border gateway with both PoE and solar as backup. In the event of a power outage, the solar panels will continue to power the gateway and the built-in supercapacitors will support operation even during the night. To connect the border gateway to the internet, you have the option to use an Ethernet cable connected to a router, or to use a mobile, 4G, network connection.
The additional SIM card slot allows you to use a local SIM card if the built-in one and its related provider do not offer network coverage in your deployment area.
To simplify installation in the forest, the gateways and solar panels are mounted on brackets.
First, attach the bracket to a pole or a tree using the U-clamps or the tree nails. Then, click the gateway and the panels into the bracket. For additional security, you can lock the devices using a padlock or zip ties. That's it.
The mesh gateway is a range extender, forwarding messages to other mesh gateways in a multi-hop network, eventually reaching the border gateway. The mesh gateway is optimized for low power consumption, and the built-in solar panel is sufficient to cover the daily energy budget.
As with the border gateway, the mesh gateway is attached to a tree or a pole using a bracket. Everything you need for installation is included. Tree nails, U-clamps, and crop wire. To attach the devices temporarily, pass the crop wire through the designated holes on the bracket. And then tie it around the tree. Later in the video, I show you how to attach the devices to a tree step by step.
Use the NFC tag on the top of the device to register the gateway and run a range test. With this test, you can determine whether the mesh gateways are connected with each other and can reach the border gateway, or whether the distances need to be readjusted. The mesh gateway, like all components of the Dryad Silvanet suite, are tree-ready. All you have to do is unpack them from the cardboard boxes, grab some tools, and head out into the forest.
To install the devices in the forest, let's introduce you to Dryad's software suite. The Site Management app allows you to plan and manage the installation of Silvanet from your computer. Additionally, there's the Mobile Deployment app that guides you to the planned location and allows you to test and activate the devices.
With the Silvanet planning tool, you can easily create an optimized mesh network for your site. You can define high-risk areas, set all sensors with high precision, and set up your connectivity network within minutes. All Silvanet devices are tree-ready. Just unpack them and bring them out in the forest. A list of all required tools for easy deployment can be found in the documentation.
We always recommend beginning the deployment with a border gateway.
Ideally, the border gateway is installed in a location with access to Power over Ethernet, PoE, a wired internet connection, or good mobile network connectivity, like at a campsite, a forester's lodge, a visitor center, etc. But even without these conditions, the border gateway connects to the internet using LTE-M or NB-IoT mobile networks, and its two solar panels ensure a reliable power supply, even in the depths of the forest. Here we demonstrate how to install the border gateway on a pole, but it can also be easily mounted on a tree. To simplify the installation process, the gateways and the solar panels are attached using brackets. To attach the bracket to a pole, use the U-clamps. Make sure that the bracket is positioned the right way around. Then insert the U-clamp through the top and bottom holes of the bracket and around the pole. Tighten the nuts by hand first, then use a wrench to tighten them firmly. To connect the border gateway to the bracket, hang the border gateway into the hooks at the top, then press it against the locking clip at the bottom, and it will snap into place. Even if you operate the border gateway on mains power, also install the solar panels to ensure uninterrupted operation in case of a power loss. The border gateway comes with 2 powerful solar panels, but to keep things brief, in this video, we show it with only 1 panel. The solar panel should be installed either underneath or above the border gateway. Don't place the solar panel directly on the other side of the pole behind the gateway, as this may block the gateway's radio waves. The connection sockets for the solar panel and the Ethernet cable, PoE, are located on the bottom of the border gateway. Remove the waterproof caps to plug in the connectors and screw them on. To register any device in the Silvanet system, use the NFC tag on the device. Open the deployment app and tap your mobile phone on the NFC symbol on the gateway. This registers the border gateway with the Silvanet cloud platform and enables you to initiate a connectivity test. The connectivity test is now running and may take a few minutes. While waiting, please keep approximately 3 meters distance from the device to avoid interfering with data transmission. When it's time to continue the test, the app will signal. You receive the results by holding your phone with the app against the NFC tag again. The test ensures that the gateway is connected via 4G, LTE, or the PoE to the Silvanet cloud platform and is ready to send and receive data. If the results are negative, please report it and find a new location with a better signal. To protect against theft, we recommend securing the gateway and the solar panels with a padlock. The border gateway is fully operational and requires no further maintenance as all Silvanet devices for approximately 10 to 15 years. It communicates reliably with the mesh gateways and the sensors, sending all data to the cloud platform, allowing you to monitor your Silvanet installation in real time. All software updates are carried out remotely. Open the deployment app.
The mesh gateway is this way.
Choose the device you want to deploy, for example a mesh gateway, and press the map button to display the planned location and your own location as a blue dot, allowing for easy navigation. The app works offline, no need to worry about having a poor LTE connection. All changes will be synchronized to the cloud when your phone connects to the internet. At the site, you must decide whether this location meets the requirements for the device. Is the tree tall and sturdy enough? Is it planned for cutting, or is it in any way unlikely to survive for the duration of the lifetime of the device? If you have any doubts, find another tree within the radius of 20 meters of the planned location. Silvanet will remember the new location of the device when you tap the NFC tag and update its location in the Site Management app.
That tree looks good.
Let's do it.
Please follow the relevant safety regulations when working in the forest. And it is always advisable to work in teams of 2. Once you find the optimal location, attach the device to the tree at a height of 3 to 4 meters, and facing south at noon. The height ensures good transmission performance, especially in hilly or densely wooded terrain. It also protects against theft and vandalism as well as interference by animals. The planning tool in the Silvanet Site Management app usually determines the device's location so accurately that a temporary installation will not be necessary. But if you have any doubts that the connection between the mesh gateway and border gateway is not or insufficiently guaranteed, first install the mesh gateway temporarily with the cropped wire, run the range test and finalize the location after a positive result. Use the chisel or an alternative tool to remove loose and crusty bark. It may also be a good idea to cut off smaller or overhanging branches if they block the sunlight from reaching the solar panel.
Could you pass me the base? Thank you.
Use the bracket as a template to mark the drill holes. Hold it against the trunk and drill briefly through the top and bottom holes to mark the spots. Put the bracket down and drill the holes approximately 6 to 7 centimeters deep using a 10 mm drill bit.
Thank you.
Then hold the bracket against the trunk again and nail the tree nails through the bracket holes into the trunk.
Thank you.
After clicking the mesh gateway into the bracket, don't forget to tap the NFC tag and run the connectivity test. This ensures that the mesh gateway is registered with Silvanet and that it has established a stable connection to the LoRa network and can reach the border gateway. The procedure of the connectivity test is now the same as for the border gateway. Wait a few minutes at the foot of the ladder for the app to signal. Then climb up again and complete the test.
Okay, let's check it. Looks good.
To protect the mesh gateway from theft, we recommend securing it with a padlock.
Oh.
the wildfire sensor. Before climbing the tree, scan the QR code on the back of the device to register the sensor with Silvanet.
And the tree looks tall and sturdy enough, so it should be good.
Don't forget to scan the QR code.
Good point.
After registering the device ID, it is linked to the GPS location. The deployment app automatically fills in the sensor's latitude and longitude using the smartphone's GPS position.
Ready.
In the deployment app, you can make notes about the specific device and place, like, "The place is a bit shady," or "Nearby is a barbecue area." This helps to track down errors more quickly if the sensor or gateway requires service. Once you find the optimal location, attach the device to the tree at a height of 3 to 4 meters and facing south. While the sensors do operate in the shade, they work better with more sunlight. If any branches are blocking the sunlight, it may be a good idea to trim or remove them. If you are deploying the device temporarily, use the crop wire. To attach any Silvanet device permanently, we recommend using tree nails. If you want to nail this sensor to a tree that has a heavy and crusty bark, carefully remove a small portion of the bark. Then drill a hole approximately 6 to 7 cm into the tree using the 10 mm drill bit. Insert a tree nail through the sensor's loop, slip a spacer onto the tree nail, then carefully hammer the tree nail into the hole. If you are temporarily installing Silvanet devices, use the crop wire for mounting. To do this, you pass the wire through the loop in the sensor and the spacer. Then you lead it around the trunk and twist the wire tightly. Tangle the loose ends so neither animals nor a storm can loosen the connection. Make sure that the sensor is securely in position, hanging loosely and vertically. After attaching the device, you may take a photo for documentation purposes. After a Silvanet sensor has been deployed, the gas sensor requires 14 days to calibrate. During the calibration period, the sensor does not detect fires. After 14 days, the gas sensor environmental readings stabilize to an optimal level of sensitivity, and it is ready to go. In this part of the video, we will show the best practices for testing the Silvanet system. A test may be useful to demonstrate the effectiveness and efficiency of the Dryad Silvanet system to an audience, media, investors, politicians, etc. For this purpose, it is advisable to equip a designated area, preferably near the border gateway, with sensors, and in a higher density than is usual, to provide optimal detection speed. The test area should be like the area where the Silvanet system is installed: a forest. A parking lot, sports field, or schoolyard is not useful as there could be too much interference for the sensor and false alarms could be triggered. Nevertheless, make sure that the area is easily accessible for the audience and consider notifying the fire brigade, which may be required to supervise the test. If the border gateway is out of range, install a mesh gateway at the test site and proceed in the same way as described in the chapter Deploying Silvanet Devices. Use 2 boxes of Silvanet sensors, 10 in each box. Make sure that the sensor gets enough sunlight and scan the QR code or tap the NFC tag. In the test site, deploy the sensors in a dense grid of approximately 10 to 15 meter distance from each other. By reducing the distance between the sensors, the detection time and amount of burning material needed for testing and validation are significantly reduced, ideal for a demo. You will find some examples of the arrangement of the sensors and the fire pit in the documentation under the keyword Testing Preparations. And just like in the deployment area, sensors must be calibrated in the planned location for 14 days. Remember, do not interact with or move the sensor immediately prior to the test. Ideally, leave the sensors alone for at least 30 minutes before performing the fire test. To prepare the fire, collect and dry burnable materials from the environment. Wood, branches, twigs, even greenery, needles, and leaves. To make the test as realistic as possible, ensure you have sufficient material to burn and maintain a test fire. We recommend burning about 6 to 8 kg or more during the test. To reflect conditions of real wildfires, the test fire should not diminish as the test runs, which should be at least 30 minutes. Use a metal fire pit with a diameter of approximately 1 meter and place it in the middle of the deployed sensors. Start the test fire by igniting small, dry branches and slowly grow the fire. Please do not use any chemical fire accelerants. Feed the fire with small branches and add smaller branches with needles or leaves on top of the fire. Constantly feed the fire with fresh material to ensure the fire continuously burns for 30 minutes and produces a lot of smoke. As the direction of the wind cannot be controlled, provide sufficient time for smoke from the test fire to hit the sensors. The sensors need to be exposed to smoke for 1 to 5 minutes to trigger a fire alert. You should expect a fire alert in the site management app and receive a fire alert email. A flashing fire alarm icon on the map displays the exact location of the sensor detecting fire. In the case of an emergency, the fire brigade can very accurately identify the source of the fire and extinguish it, which they should also do after a successful test of the Silvanet system. Make sure you completely extinguish the fire after the test and do not leave any ember behind. But what remains is the feeling of having done something to protect the forest, the animals, and the people with the Dryad Silvanet system.